Hey, welcome. Today, we're not just talking about code that, works. We're going to build the complete blueprint for a real deal enterprise grade Spring Boot application, something that's robust, scalable, and totally ready for the real world. We've all been there, right? The app runs perfectly on our laptop, but what happens when it suddenly has to face thousands of users all at once, or deal with weird inputs you never expected? That is the huge question we're tackling today. It's really the difference between a fun little project and a professional, truly resilient system. So here's how we're going to break it all down. We're going to walk through this step by step, starting with a solid design, then building in all the necessary quality checks, and finally paving a reliable path to get it out into the world. All right, first up, architecture. This is, without a doubt, the most critical first step. I mean it. If you get this right, everything else that follows just becomes so much easier. Okay, what I really love about this three-layer flow is just how clean and simple it is. Think of it like this. The controller is your front desk receptionist, taking in requests and directing traffic. The service layer, that's the expert in the back office, where all the real thinking, the business logic happens. And finally, the repository is like the meticulous archivist, handling every single interaction with your database. This separation is awesome because it means you can swap out your database or change a business rule later on without, having to rewrite the entire application. So, how do these layers talk to each other without spilling all their secrets? Well, that's where DTOs, or data transfer objects, come into play. Just imagine your internal user object has sensitive stuff, like a password hash. You never want that to leave your system. A DTO acts like a secure courier, carrying only the data that's needed, like a username and email, to the outside world, while keeping your internal database structure totally hidden. It's a massive shield for security and flexibility. And this slide right here illustrates a super important choice you have to make in your code. Using constructor injection forces you to be upfront about what your components need to function. It makes everything clear and, crucially, way easier to test. Field injection might feel quicker, but trust me, it often hides problems that will come back to bite you later on. Let's be real for a second. Things are going to break. Connections will drop, users will enter bad data. It happens. But instead of plastering error-handling code all over the place, a global exception handler acts like a central command post for any and all errors. In Spring Boot, the @controller advice annotation is perfect for this. It ensures that no matter what goes wrong, the user gets a consistent, clean response. It just makes your app feel so much more professional, and it's a lifesaver when you're trying to debug problems. Okay, so we've got our foundation poured. Now it's time to build the safety net, because a great architecture means nothing if you don't have a solid testing strategy to prove it actually works. This really breaks down the two main kinds of tests you absolutely need. Think of unit tests as checking each individual brick. You're making sure every single tiny piece of code does exactly what you expect. Then you have integration tests. That's where you check the whole wall, making sure all those bricks fit together perfectly and can talk to external things like your database. But wait, how do you test one brick without needing the rest of the wall? Simple. You use mocks. A tool like Mockito lets you create a sort of stunt double for your database or for another service. This lets you test your one component in total isolation. So if something fails, you know the problem is right there in that one piece of code. All right, let's move on. Now we're going to bring in an automated inspector. This is all about setting up a quality gate that no piece of code can get past unless it meets a really high standard. This number right here, 80%, this should be your North Star for testing. It stands for code coverage. It's basically a measure of how much of your code is actually being run by your tests. If you're hitting at least 80%, you're in a good spot. It means you're not leaving huge chunks of your application completely untested and vulnerable. And this chart, which is what you'd see in tools like SonarQube, just gives you a really clear visual target. You want to be in the green. Above 80% is a strong indicator of a healthy, well-tested code base. Anything less than that, well, you're rolling the dice. Now for a term that sounds way more complicated than it is, cyclomatic complexity. Honestly, just think of it as a spaghetti code detector. It counts how many different decision paths or branches there are inside a piece of code. A low score is good. It means your code is like a nice, straight road. A high score means you've got a tangled mess of if statements and loops, which is hard to understand, a nightmare to test, and just a perfect hiding place for bugs. The goal is simple. Keep this number low. So, our application is beautifully designed, it's been thoroughly tested, and it's passed all its quality checks. Now it's time for the exciting part, creating a rock-solid pipeline to get it out to our users. Docker. This is the ultimate fix for that classic developer excuse, but it works on my machine. By defining everything your app needs in a single Docker file, you package it all up into a neat little container. And that container will run the exact same way everywhere, on your machine, on the test server, and in production. No more surprises. And this is the automated assembly line for your software. It's called a CI/CD pipeline. The magic here is that the moment a developer commits new code, this whole process kicks off automatically. The system builds it, runs every single test, and if everything passes, it deploys it. This isn't just about being fast, it's about being confident. It means you can release new features constantly, knowing this automatic process has your back. Okay, remember, deploying your app isn't the finish line, it's the starting line. Once it's live, you have to be its doctor, constantly checking its vital signs. Are requests taking too long? That's your response time. Is the system getting bogged down during busy hours? That's throughput. Are people seeing error pages? That's your error rate. Watching these metrics is how you spot problems before they become major disasters. Wow, we've covered a lot of ground, from the first sketch of the architecture all the way to deployment and beyond. So let's wrap it all up with a simple, actionable checklist. And here it is. This is your final takeaway. This isn't just a list of nice-to-haves. This is your checklist for building like a pro. If you can confidently tick every single one of these boxes, then you know your Spring Boot app isn't just working, it's truly ready for production. And really, that's the question this whole blueprint helps you answer. Because following these principles isn't just about making sure your software works today, it's about making sure it's robust, scalable, and maintainable for years to come. It's about building something that